So temperate forests, I think, are the forest ecosystems, probably just the ecosystems in general that you are most familiar with. They may be the ones that are, because of that, are the most important to you. All temperate forests have distinct seasons. The degree to which those seasons are different is widely variable across them. Just in our class itself, we have, many of us here in California in a relatively warm and mild climate. And then if you're from elsewhere in the country, including, say, up in the northern part of the country, it is quite cold during the winter. I can't remember if I mentioned this to you, but I'm from Arizona. I meant to kind of give you more details about that during the first class, but I'm from Arizona. I'm from the mountains. Arizona is like California in that it's a warm climate, but it's cold in the mountains. I moved after doing my degree to Maine, to the University of Maine, where I did a forestry degree, and that is an environment, still a temperate forest, but with a long and cold winter. So, there's variability. But in general, temperate forests have a distinct winter, but they're not so cold that they cannot support broadleaf species. And that's going to be one of the most important distinguishing characteristics between temperate forests and boreal forests. Generally, they have a long growing season. Again, it's variable depending on where you are in that broad range. And they have this interesting thing that even though the growing season is relatively long, the distribution of precipitation it tends to be even throughout the year, but variability in the distribution of precipitation creates shifts between vegetation types. In particular, temperate ecosystems where the precipitation is dominated by winter rains, that climate dynamic tends to favor conifers over evergreen broadleaf species. One of the best examples of this, and it's one that I'll mention a couple times, is the Pacific Northwest. As you go north into California and into Oregon, you start to have a dominance of winter rains, and that shift tends to favor things like Douglas fir and other conifers. Now, when you contrast this with the upper Midwest, parts of the upper Midwest, and the Northeast, even much of the South, where you have more even distribution of precipitation throughout the year, you'll start to have forests that are dominated by broadleaf species. So in New England, particularly in southern New England, where, like I say, there's rain throughout the year and it's not too cold, you have forests that are dominated by oaks and maple and a number of other hardwood broadleaf species. The first kind of type of forest within this that I want to highlight is the one that's most familiar to us here in San Luis Obispo. Mediterranean forests are kind of a special designation because they have some distinct differences, but you can broadly classify them as within temperate forests. These are forests where the precipitation is restricted to the winter. It's very strictly winter precipitation, and where you have this long seasonal drought. You might take it for granted, especially if you're from California, you may take the long winter drought summer drought for granted, but it's super weird. If you've spent time in other forest types, other ecosystems, this is not a typical thing. Most forested landscapes have precipitation in more than just the winter. And that drought, a 6-month drought, say in the forests of the Piedmont in Georgia, or in Appalachia, the mountains of Tennessee and places like that, a 6-month drought would be absolutely devastating. I mean, regional scale forest mortality. Those of you that are forestry students may have read about or even studied a series of fires that happened in Tennessee. I think it was 3 years ago in Appalachia, up in the mountains. There was a real devastating wildfire in the mountains of Tennessee that killed a number of people. And that occurred after a 4-week drought. That was a very long drought for that particular ecosystem. 4 weeks is nothing here. That would be a drought in the Mediterranean environment that's only 4 weeks long would be strange because it was so short. But there it was virtually devastating. Everything dried out and burned up really fast and damaged a lot of homes and cost quite a few lives. But Mediterranean forests, like I say, these seasonal droughts, they occur. It tend to be hot climates. So you think about places like south of Portugal and a lot of Spain, Australia and South Africa. These are relatively hot climates, especially in the summer. They're not strictly hot. They can be, kind of foggy places. Frosts are rare, but they do occur. And you tend to have 2 broad classes of forests. You either have evergreen forests or drought deciduous forests. And you can see both, and you probably have seen both just here in the San Luis Obispo area. Most of our forests are evergreen, are oak forests. But if you go to the east of here, you'll start to get into blue oak forest. You don't have to go very far, but you start to get into you only have to go to Atascadero. You start to get into hotter, drier environments, and blue oak and some other species like Aesculus, the buckeye, those are drought deciduous forests. Those trees, the trees that dominate those stands, lose their leaves every year. And it's just a response to the seasonal drought. Here's a map of Mediterranean forests. The forest type is named for the Mediterranean basin. That's where they are the most widespread. These, I guess it's 5 places in the world that have this kind of forest type, and they all share a couple things in common. They're all about the same latitude, north or south. They all are locations where there is a cold ocean current, and that cold ocean current is important in creating this, this dominant winter precipitation dynamic. So the direction of the currents and the source of the currents is different in each one of these, but they end up having the same kind of climate dynamic. And what I want to point out here is that the forests with a distribution of dominant winter precipitation is actually broader than Mediterranean forests. So for example, the Sierra Nevada is a mountain range with forests that have dominant winter precipitation, but I wouldn't call them Mediterranean. Those are temperate conifer forests or montane temperate conifer forests. As you look around in the world, you have places that are like that. The highlands of Ethiopia, some parts of the greater Mediterranean basin and Western U.S. But anyway, that's just a little bit more context. So yeah, I've been to a number of these forests. I haven't been to South Africa and I haven't been to Chile, but I've spent a fair amount of time in Europe and gotten to see these forests in a professional capacity. This is the south of Spain. These forests look a lot like our forests here in San Luis Obispo. I find them to be hotter. Drought deciduousness, I'm not as species that are drought deciduous in that environment do not come to mind as readily. It does have this interesting thing where a lot of these forests, and this is a cork oak forest, Quercus suber, which is of course the natural source of cork. These forests, they have an annual leaf cohort, but they're one of these species that loses their leaves at the same time that the new cohort comes on. Anyway, I really enjoyed my time there. Here's a photograph from Lake County, and this is in a lot of ways the climate dynamics are similar to San Luis Obispo, but this is different oaks. This one is excuse me, a photograph of interior live oak and some gray pine and some blue oak. And what you've got there is blue oak is drought deciduous, and the interior live oak is evergreen. So, you know, those two things can happen at the same time, kind of overlap. As you go north, you transition into a climate that is cooler and wetter. You know, winter precipitation is still dominating. As you move north, particularly along the coast, you start to see a greater dominance of conifers, and particularly conifers that are more adapted to a Pacific Northwest type environment, specifically Douglas fir and redwood. Eventually, as you get into Oregon, redwood peters out pretty fast, which I think is about frost tolerance. I'm not actually sure. It's kind of curious why redwood would peter out so fast, but it does. You can kind of see this as you move up. You know, this is Humboldt County, lots more conifers. I don't know if it's right to call Humboldt County a Pacific Northwest environment. It's a transition environment. It's definitely more dominated by conifers, but it's, you know, I wouldn't compare it with a place like Astoria, Oregon, or, you know, Tillamook and places like that, which are a lot foggier and a lot wetter. But it's certainly wetter than here in San Luis Obispo. I can say that with a lot of confidence. And then once you get up into that, you know, the area around Tillamook, you know, kind of in northern coastal Oregon, it's just straight dominance from Douglas fir. Lots of winter rain, some winter snow, not a lot, but some. Even more conifers. This is a great environment for growing conifers and for just producing, for producing timber. There's rapid tree growth here, and these are really high economic value forests. It's a really great environment, like I say, to grow Douglas fir. There are still hardwoods here, though, and that's the thing to point out. There are, in particular, alder in this environment, but depending on where you are, you'll find some white oaks and stuff like that. So there's still variation on a small scale that may favor one type of species over another. Anyway, there's the unmarred photograph of Northern Oregon. And of course, that's a clear cut there in the foreground. And that's a good way to grow, an efficient way to grow Douglas fir in this area. It's a lot of input, you know, planting, thinning, herbicides, but you can grow Douglas fir quickly. You can grow high economic value Douglas fir, and it's really important for the local economies. And Douglas fir is just a great thing to build like a house or a structure with. It's really nice wood. It's mills easily, it's strong, it's flexible, it's really great. Yeah, okay, sorry, here's the Mediterranean environment again. And, oh, right, I think I put that there just to remind myself that I was gonna just show some photographs from elsewhere in the world. And this, my old boss took this photograph when he was down in Chile. This is a monkey puzzle, it's an Araucaria. I mentioned it in the online materials. These are Araucaria are conifers. They're weird conifers. You know, these southern hemisphere. It's a southern hemisphere genus, but it didn't evolve there. These are really old trees, and you know, if you see artists' illustrations of dinosaurs and stuff like that, you'll oftentimes see trees that look like this. And that's not necessarily an inaccurate thing. Araucaria has been around since the time of dinosaurs and such crazy creatures. And they were once distributed across the globe, and now they're restricted to the southern hemisphere. These forests, I mean, to me, they seem very familiar. They look very similar to a lot of the Sierra Nevada. For example, in the mid elevation range, where you have a mix of firs and ponderosa pine and black oak, you know, where you have like a winter deciduous tree intermixed with conifers. That's what this reminds me of. This is the foothills of the Andes, and what you've got here is you got a similar kind of phenological or seasonal dynamic here, but wildly different species. You know, in Sierra Nevada, like I say, this kind of dynamic would be something like ponderosa pine and black oak, but here it's Araucaria and Nothofagus, which is a broadleaf species. Cool. Yeah, so temperate broadleaf forests. This includes a couple of different designations. I'm going to mention this map has broadleaf rainforests as well as broadleaf deciduous forests. So the deciduous forests tend to have a more pronounced winter, whereas broadleaves or the rainforests are going to have very rare frosts. I'll come back to those in a minute. The temperate broadleaf forests are pretty broadly distributed. You know, a wide swath of the temperate zone, particularly in the northern hemisphere. So the north of Europe, the east coast of the United States, north and coastal China, Korea, and that far eastern part of Russia, most of Japan, and then some of the mountainous areas, particularly in Australia, and of course all of New Zealand, which really isn't Mediterranean. So what do these forests look like? They tend to have even precipitation throughout the year, kind of alluded to that before. And it's not doesn't seem to be an accident that they're dominated by broadleaf species. Those things go hand in hand. This is a photograph from Massachusetts. That's birch there in the Northeast. These forests are, well, throughout in all of Eastern North America, these forests tend to be more diverse than we, in terms of overstory tree species. They're more diverse than what we see here locally. There are a number of birch species, ash species, a Fraxinus, like I mentioned, maples and oaks, a number of other species, Nyssa, which is what is the name for a sweet gum? That's another species, kind of a species that oftentimes is the oldest trees in the New England landscape, mid-Atlantic. Pretty cool. Yeah, they're very diverse. The forest with the greatest diversity in terms of overstory tree species, I think, period, greatest biological plant diversity in the U.S. is in the East Coast. I think it would be classified as Appalachia. It's wet enough, it's warm enough, there's a lot of evolution of new species, a lot of variation in ecological niches. And a lot of these species they're valuable. They have good timber quality, they are important for wildlife, they grow fast or they grow slow, and create lots of structure and provision water and do a lot of things that are valuable to society. Let's see. Forests with even distribution throughout the year. Oh yeah, I wanted to mention that even within these landscapes, you still have conifer dominance at certain local scales. So this is a photograph of eastern hemlock, and here you've got a stand that is all conifer dominated, but what's happened here are a couple of things. You've got poorer soils. Sometimes soils with poorer drainage will favor conifers. Sometimes soils that just have low nutrient levels will favor conifers. And sometimes there's a factor of land use. For example, in New England, the lots of the hemlock stands, which is one of the important conifer stands in that landscape, those are, their distribution is related to what happened in the 1800s. Specifically, what land was cleared for agriculture and what land was kept as a woodlot. In the areas that were used as woodlots, they tended to be areas that had poor soils anyway, and then cutting and the combination of cutting and management and poor soils led to more hemlock dominance. And here's just another photograph from this landscape. If you don't know New England, there's a lot of diversity, pretty cool. I lived there for 9 years in Maine and Massachusetts, really important part of my career. I got a lot out of it. Still have a lot of friends up there, and the forests are pretty cool too. I'm glad that I had that experience, if nothing else, just to learn about this different ecology. And here's something kind of interesting. Broadleaf rainforest, temperate broadleaf rainforest, there are very few of them left. Very, very few of them left. These are areas with mild winters, so rare frosts, but lots of rain, so consistent rain. The distribution of these are very restricted in North America. There maybe it seems that there's a little bit in Florida. They were more common in the Southern Hemisphere, but most have been converted into pasture and farmland. I got to see this firsthand just this summer when I was on the North Island in New Zealand. Here's where it's thought that these forests would have existed. And, you know, you see kind of the Pacific Northwest highlighted a little bit here. A lot of that is actually dominated by conifers. There's the potential for some of it in some parts of Europe. Galicia, which is the very far north of Spain, especially the northwestern part of Spain. It's actually it gets year-round rain, and then parts of Scotland, Ireland, Cornwall, some Wales, like places like that have forests may have had this kind of forest type. The frosts are rare and they're pretty wet. Japan probably had some too, especially in the islands off the East Coast. Did I show a picture of Tani Mahuta? No, I haven't shown it. No, I haven't shown Tani Mahuta. Really?
Yeah.
Did I show Tani Mahuta?
Yeah.
Okay. Well, oh well. Anyway, this is Tani Mahuta. It's one of the largest trees in the world. Was down in New Zealand to work on a disease problem with this that affects a species, and that's in this temperate broadleaf rainforest. So Tani Mahuta, it's kauri, that's the common name. It's an araucaria, just like those like monkey puzzle, the species I was showing you from Chile. It occurs in this area as part of the world that would be temperate rainforest. I really liked it down there. I really like New Zealand. I've gotten to go there twice for work. People are nice. The beer and wine is good. The mountains are really big. It's a cool place. And I was glad to spend some more time in the North Island. It's just more mild and it's a lot wetter, and there's a lot of really kind of crazy species there. This is Tani Mahuta on the left, and then just a picture of the forests. And here's just some examples of the stuff. You have like these tree ferns on the left, they're pretty crazy. And this thing on the right is called celery pine. That is a conifer. That's a conifer. Think about that. Conifers that you're more familiar with probably have, like, you know, needles, things like Douglas fir and stuff. So anyway, I thought that was pretty cool. And here's some more. That's Manuka. The thing that I always point out about Manuka is how valuable the honey is. This is like a understory shrub. You know, 100 grams of the honey from this thing sell for like $40 or $50 down at Lassen's It's got some anti-inflammatory compounds in it. So anyway, that's Manuka. Tastes pretty good. Tastes pretty good. I don't buy the $50 100-gram, honey, but you can if you like. You should wear a mask when you go. And this is just if you don't know about New Zealand, it had, I think it was virtually no endemic mammals prior to people arriving there. And so a lot of the ecological niches that would usually be, kind of occupied by mammals in most of the temperate hemisphere, temperate part of the world, are actually occupied by birds. And there's just a lot of just crazy bird diversity there. So anyway. What I want to kind of leave you with here is that just kind of reminding you that a lot of these forest designations are arbitrary. When you go out in the field and you try to look at ecosystems to try to make sense of them maybe for professional purposes, ask, what is this and why? How might I manage it? Just remember that a lot of these ecosystems the designations are arbitrary and transitions are really common. And the problem that we run into a lot in working in forests is that, especially as we move up slopes, temperature decreases and precipitation increases. And that can create some pretty kind of fuzzy dynamics, or fuzzy boundaries, I should say. The dynamics maybe not that fuzzy, but the boundaries are. This photograph is from the highlands in Mexico. It's Volcan Tajumulco, and just, this is an example of moving from kind of a desert up into kind of a scrub ecosystem and then eventually up into a pine forest. But I think the one that's probably the most familiar is the Sierra Nevada. It's certainly the closest to slow. Cooler and wetter conditions predominate as you move up the mountain. And that creates this slow transition, in particular from broadleaf to evergreen dominance. And this is, took this photograph at lower elevations near Big Oak Flat. I think that's, where's the Iron Door Saloon? Anybody been there? I can't remember. What's the name of that town? Somebody from that part of the world? Been through the north entrance of Yosemite? Anyone? Anyone? Bueller? Bueller? You guys get that, right? Good, okay. I saw at least one nod. Anyway, I lost my train of thought here, but what's happening is low elevations, broadleaf dominance, lots of scrub. As you move up, you start to get higher statured forests. And you also start to have you do get a dominance of broadleaf species, and this is in Yosemite Valley where you've got interior live oak and a lot of black oak. There's variation here in the valley. You got evergreen broadleaf species dominating on the south slopes because they're hotter. And then if you go over, just walk a mile across the valley onto north-facing slopes, you've got conifers dominating. And as you go up the slopes, even the south-facing slopes, you have conifer dominance until you get up into the high country, like up in Tuolumne and stuff like that, where it's just too cold. It's just too cold, and then you kind of have this shift back to conifer dominance.